everybody. This video is about finding the centroid of a shape that's a composite of other shapes. So in the appendix, you're going to have the centroids for common shapes, like there's rectangle, circle, triangle, semicircle, things like that. So then you don't need to integrate, you just have it right there in the appendix. So then if you have an object that is a composite of these simple shapes, like let's say you have something like this, you don't ever have to integrate this, because you just look at it and say, it looks to me like a triangle stuck to a rectangle. And then I can look up in the appendix, the centroid of the triangle is here. The centroid of the rectangle is here. And since a centroid is an area-weighted mean position, the centroid of a composite is an area-weighted mean position of the centroids. So I'll just show by example. Let's say this is x and y, and we know this is the x component of the centroid for the triangle, and then like here to here is for the rectangle. The centroid, let's just say the x component of the composite, is the area-weighted mean position of the centroids. So the centroid for the triangle times the area of the triangle, this area here, plus the x component for the centroid of the rectangle times this area of the rectangle, divided by the area, the total area. Right, so see how it's an area-weighted mean position of the centroids? Same analogous for y. You just go for the rectangle divided by. Right, so now this is the area-weighted mean position for the y component of the centroid. Okay, best way is to show by example. Let's say you have a shape like this. Where's the centroid? Okay, it looks like a rectangle, a triangle, and a semicircle. And the centroid for the rectangle is here in the middle. For the triangle, here, according to this from the appendix. And then for the semicircle, according to this from the appendix, here. So let's go with the x component. Where's the centroid? It's for the rectangle times the area of the rectangle plus the centroid of the triangle times the area of the triangle plus centroid of the semicircle times the area of the semicircle divided by the total area. So let me just plug in numbers. So for the rectangle, it's in the middle, right? So right here, 2 feet. 2 feet. What's the area of the rectangle? 3 times 4, 12. Okay, plus the centroid of the triangle. So it's 2/3 of the way over. So I'll just say 2/3 of 4 feet. And then what's the area of the triangle? 1/2 base times height. So this is 4 feet, right? Because this radius is 2. So 1/2 base times height. Okay, and then where's the centroid for the semicircle? It's right here. So that's 4 plus however far this is, 4r over 3 pi. r is 2 feet, right? Times the area of the semicircle, 1/2 pi r squared. Okay, divided by the total area. 12 for the rectangle, 8 for the triangle, 1/2 pi r squared for the semicircle. And then that's it. Right, and analogously for y. Okay, let's try another example. Oh, what happened over here? There's a cutout. Right, so there's a cutout. So for a cutout, you just treat it as having a negative area. That's all. So for example, let's say we want to find x. Okay, I'm going to just start plugging in numbers just to explain quicker. So for the rectangle, the x component in the middle, so 5. And then the area of the rectangle, 8 times 10. Okay, now for the circle, the centroid is 4. But the area is, it's a cutout, so negative pi r squared. R is 2 inches, right? And then the triangle is here, right? So that's 10 plus 1/3 of the way over here. And then the area of the triangle, 1/2 base times height. Okay, and then divided by the total area, 80 negative pi r squared. There we go. Okay, how does it look? Not too bad. Okay, one more. So there we have this vertical stabilizer for an airplane. Where's the centroid? Okay, so it looks to me like a rectangle with this triangular cutout and this other triangular cutout. Right, so for the rectangle, right, it's just in the middle. For the triangle, we're going to need, let's see, this number, call this x1, and this number, call this x2. Okay, and let's take a look. So this angle is given, and this angle is given. So let's just, oh, and then this is known. So let's just do some trigonometry here. So for this triangle, let's see, we know this number, and we need this number. So we know opposite, we need adjacent. So tangent, that is opposite over adjacent. Okay, so then we can solve for that. And then for this triangle, we know adjacent, we need opposite. Tangent 48 is opposite over adjacent. So we can solve for this. Right, so then you know the dimensions of the rectangle, right? Like this. And then you know the dimensions of each triangle. So then you can find the centroids of each of the 3. Okay, so give this a try. Let me know how it goes. So I'll see you on the next video.